Next up, we have the Medical Informatics and Systems Division.
Hi, I'm Skip Garner. I direct the Medical Informatics and Systems Division. The way in which we're going to do this today is that each of the principal investigators, is providing one slide, and it's just to kind of stimulate the general description of the kinds of work they do. And so I also want to emphasize that we're really into translation and to getting our results into the clinic. And as such, we not only have our science in here, but I think, last count, at least three spin-out companies for the division. And I want to start this off by actually giving you my slide before we move on to each person. And so what this is a description of our work where we now have developed techniques to rebuild every genome, especially the junk part of the DNA that's often ignored. And we focus on repetitive elements or microsatellites or sequences that go like CAG, CAG, CAG. What we found when we started to do this process is that all current assembly engines get it right about 20% of the time. So only 20% of the time do they obey Mendelian inheritance, which is something that we kind of believe in. And so we rebuilt all those algorithms and went to an entirely different approach, and now we're building all the loci at microsatellite at about a 96% accuracy, which then allows you to do discovery, which was not possible before. So this is one example of the platform technology. Now we've done about 10,000 genomes, completely rebuilt them from scratch. For about a dozen different cancers. This happens to be breast cancer. Through the analysis of about 600 or so germline sequences and a couple hundred matched genomes, we were able to identify 55 loci that were robust and independently determined and passed stringent false discovery rate tests, et cetera. And once we identified those, we could do a number of things with them, including building a signature that could predict the potential for risk for developing breast cancer from looking at the germline, i.e. from blood. And this just happens to be the results. The blue bars here is the general population, the matched population there of people who are cancer-free. And they primarily do not have the alleles that contribute to the risk, and these are 55 new loci with all new alleles that were previously undiscovered. However, when you look at the germlines of the breast cancer patients, not the tumors, but the germlines, you can see that they kind of sequester in an area where they have genotypes that are unique to cancer. And of course, you can see that the red is the germline, the orange is the tumor. The tumors also haven't inherited this pattern of risk markers. And what this has allowed us to do is to identify, using receiver-operated curves, to draw a line and then to develop a diagnostic test where if you're on this side of the diagnostic test, you're at low risk for developing cancer. Here you're at high risk. And we've done this for prostate cancer, a variety of brain cancers, ovarian cancer, et cetera, and published all this stuff. So this allows us to now move this to the clinic, and we're now independently validating these at other universities across the United States, across the world, sorry. And for our test, the sensitivity is about 88%, the specificity 77%. Now, the reason why I want to bring that up is that breast cancer is the best genomically diagnosed cancer in the world, and it's largely through the analysis of the BRCA1 and 2 genes that, as you know, if you read the papers, Myriad and others have kits for that. And just so you know, about 8% of the people who develop breast cancer are positive for that test, so their sensitivity is around 8% if you measure it in a similar way. The other thing that you should know is that 12% of all females will develop breast cancer at some time in their life. And so as a consequence, the specificity at best you could get is something at the 85 to 90% range. Okay, and so what this is one of the many new diagnostic tests, the basic science that underlies the new diagnostic tests that are now impaneled so that we can do all this stuff. And as opposed to having one test for each gene that runs you $2,000 or $3,000, Our cost of goods currently is about $200 to test your risk and also do a variety of other diagnostic tests to partition you for all these at one time. Okay, so thank you very much, and next slide, please.